In this section, we'll be seeing the concept of outliers. I'll be showing you what's the difference between a one-dimensional outlier and compare it with a two-dimensional outlier. But to do this, I'll just grab a data set. I can just go to File, Open, Data, and I've got a data set here which is called as car sales. Let me just pull out this data set. Now, as you can see here, you've got very, very important variables like manufacturer, model, sales, resale value, type, and other important details like what's the price of the car, engine size, horsepower, wheelbase, width, length, so on and so forth. I'll not be working with all these variables. I'm mainly interested in this particular variable, sales. And as I scroll to the right side, you will see a couple of important variables like mileage per gallon. So I'm interested in MPG, which stands for mileage per gallon. This is the variable that is prominently used in the US. And of course, you have got the variable sales. So to do a one-dimensional outlier, the best weapon that you have, the best way to do a one-dimensional outlier would be through a box plot. Question is, how do you do a box plot? In the Analyze menu, you can use the second option, that is Descriptive Statistics. Within this, you have the third option, which is called as Explore, right? So please click on Explore. Now, the dependent list is the place wherein you can supply any scale variable. So I have the variable sales in 1000, which I'll choose as the dependent variable. I want to choose another variable here, which is mileage per gallon. The mileage per gallon is referred to as fuel efficiency as far as the variable label is concerned. So I'll enter these two scale variables. Now, if I choose the option both, it'll display a lot of statistics and plots. So I'll avoid this particular option, and I'll click on the option plots here. I'll just ignore the option both here and click on the option plots. Now I'll just click on OK. As you can see here, it is showing some output. The first box plot here, as you can see here, you're getting a box plot. You're aware of what all important details that it shows, but a very, very easy and effective way to sort of show the values for outliers would be these. The ones above the maximum can be called as outlier. You can see quite a few cases like 57, 53, 138, 41, so on and so forth. Remember, in SPSS, the moment it puts a star mark, it's extreme value. And wherever there are circles, you can call it as an outlier. So this is a very, very simple and an effective way to show an outlier. Now, this is as far as sales is concerned. Now, if you want SPSS to go back to the data set, and in the data editor, if you want SPSS to highlight all these cases, there's a way to do it. I can just double click on this particular graph. Once I double click on this graph, I can just select all the outliers, right click on the graph and say, go to case. So you can see here, it has highlighted quite a few cases which it thinks is an outlier, right? As far as sales is concerned, quite a few, quite a big value as far as sales is concerned, 227 point something, 181, 245, 175, 276. All these are values of sales which can be called as an outlier. Now, what I wish to do here is this. I'll just show you the second box plot here. I'll quickly close the chart editor window. The second box plot is for the variable fuel efficiency. And you can see here, there is one case here, which is an extreme case, and this corresponds to a value of 45. So the 27th case is called as an outlier. How do I highlight this in the data editor? Do the same thing, just click on it, right? Select the outlier, right click on it, and then say go to case. You can see here, there is a model of vehicle which is called as Metro that can be considered as an outlier. This is the only outlier as far as MPG or mileage per gallon is concerned. Now, a box plot is fine when you want to find out a one-dimensional outlier. When I say dimension here, I'm referring to a variable. Mileage per gallon is a variable here, as well as sales is a variable. With respect to one variable, if you want to find out the outlier. It's pretty simple. That is, you can always take the help of a box plot to show a high value of an outlier or a low value of an outlier. Now, when you have two variables, and if you want to show an outlier, how do you do it? Now, this is where we are going to look at what is called as a two-dimensional outlier. Now, you may ask me as to where is a two-dimensional outlier used. Two-dimensional outliers and such things are very, very important, especially if you're doing a simple linear regression or if you're doing a Pearson's correlation. Then identifying a two-dimensional outlier becomes a prerequisite. If you don't identify an outlier and remove it, you may get outrageous values, and therefore it's always good to recognize these outliers and remove these outliers and take care of these outliers, put them in a different data set, or and then go ahead and do your Pearson's correlation or find out a regression coefficient, whatever the objective of the project is. Now, at a very, very high level, I wish to show you how do you do a two-dimensional outlier. A very, very simple and an easy way of doing a two-dimensional outlier is through a scatter plot. Now, I know that a scatter plot is used to find out the nature of relationship. If you want to find out whether there is a linear relationship or a non-linear relationship between the dependent variable and the independent variable, you normally use a scatter plot. But here, my objective is slightly different. My objective is to highlight outliers, two-dimensional outlier, if any, in the data set. To do this, what I'll do is I'll just go to the graphs menu, and right at the top, you see chart builder. So please click on the chart builder. Now, in this particular chart builder, what I wish to do is I wish to sort of go through each of these things, but you have a long list of options here. I will click on the option scatter plot. Now, you see a variety of scatter plots here. You see 9 different scatter plots that SPSS gives you. I'll just double click on the first of the scatter plot. The first of the scatter plot is a simple scatter plot, right? Now it is asking me for the y-axis as well as the x-axis. Now y-axis here is the first variable that you want to show, which is sales. Now, once I do this, I will be choosing the second variable, and the second variable is nothing but my mileage. So this is the x variable. Now I have shown scatter plot. I'm interested in showing a scatter plot with sales along the y-axis and fuel efficiency along the x-axis. Now it asks for a filter. I'll ignore this and I'll just quickly click on OK. Very, very interesting. This is how your scatter plot looks like. Now, I do not see any great pattern here. I don't see any linear pattern or a non-linear pattern as far as the data distribution is concerned. What I see is a random distribution of data points. I'm getting fuel efficiency along the x-axis, and I'm getting sales along the y-axis. Now, what I see interestingly is there is one particular value here which sticks out from its neighbors. I see a cluster of values in this region. There's one value corresponding to y-axis. That is basically a value which is crossing 500 as far as sales is concerned. And as far as fuel efficiency is concerned, there is one value here which is standing out from its neighboring values. This is again a value which can be called as an outlier. So my observation, my first observation when I look at this scatter plot is that there are two values which can be designated as outlier. One is the value for sales, which is exceeding 500, and the second is the value which is corresponding to fuel efficiency over a value of 45. Now, it's one thing to get these outliers. So at this stage, we can confidently conclude that there are outliers in the data set. There are two-dimensional outliers. But the question is there a way in which we can pull out the names of these two values? Now, to do this, what I'll do is I will go back to the scatter plot. And to do this, you can just click on recently used dialogues. I have used the chart builder. So let me just click on this. So it just shows the scatter plot, which I've just now used. Now, right at the top, you see a lot of options here. I'll click on the third option, which is known as groups /point ID. Now, what does this help me do? This helps me name each and every value of each and every value in the scatter. I'll choose the last of the options, which is point ID label. Now, this is very interesting. There is a new box which appears. Now, this helps me label each and every value in the scatter plot. I will ignore filter option here because I don't want to use any variable as a filter. Now, what is the value? What is the variable that you need to supply as far as point label variable is concerned? Now, you can choose any row identifier which is unique. Had it been an employee data set, I would have chosen employee ID or employee name, but this is not an employee data set. This is car sales data set. So model of the car is very, very unique. So I'll choose model and I'll drag this and drop it on point label variable. You have to drag this and drop it exactly inside the rectangle, or else you'll not be able to get this. So please choose the option OK. Wow. Look at this. The moment you choose this option, it adds a lot of life into this scatter plot. Take a look at the earlier scatter plot that you got. It was basically dead. It was lifeless. It just showed you the distribution. But the moment I choose to label each and every data point, this is how I get. It is pretty obvious that you have a lot of vehicles here, especially corresponding to Civic, Focus, Corolla, SL, and other vehicles here like Explorer, which are part of the cluster. But as far as my goal here is concerned, that is F series, that is a value which can be called as an outlier. This is a value which can be called as an outlier. Now, there's another value which is called as metro. This is the second observation which can be called as an outlier. Now, this is how you can identify an outlier, right? Now, the best way to identify a two-dimensional outlier is a scatter plot. Firstly, find out whether or not there are outliers. Once you come to the conclusion that there are outliers in the data set, you might want to label it, and therefore you can label it through the option group/point ID. It labels each and every point on the graph. So this is a very, very easy way of identifying the outlier. Now, if you want to go back to the data set, right, you can just choose the variable model, right? You can choose the variable, you can select that entire column and just click on Control F. It's just going to find out the outlier, METRO. It is case sensitive, so M is in capital letters, the remaining letters are small. So I'll just click on the option Find Next. Does it identify? Yes. The manufacturer is Chevrolet, and it gives me all the details pertaining to Metro, which can be called as an outlier. Now, what I'll do is, this is the first of my outlier. Now, let me just identify the second of my outlier, that is F series. F is in caps, there is a hyphen, and then series. S again is in caps. I'll choose the option Find Next. You can see here the 57th case corresponding to Ford is again a value which can be considered as an outlier. So to summarize, we have seen how to do a one-dimensional outlier through a box plot. We have also seen how to identify a two-dimensional outlier through a scatter plot. Now, the obvious question in your mind could be, how do you identify a three-dimensional outlier? Is it possible through a graph? The answer is no. It's very, very difficult. It is not so easy to pinpoint through a graph. How do you identify a three-dimensional outlier? What about a four-dimensional outlier or a five-dimensional outlier or a 10-dimensional outlier? Graphs are not good enough to identify an n-dimensional outlier. When I say an n-dimensional outlier, n which is greater than or equal to 3. More than 3, you need an algorithm which can help you identify and pull out those cases which have given extreme values. Now, this is where mainly in banking domain and insurance domain, if you want to identify fraud cases, if you want to identify extraordinarily large claims made by people, you can use an n-dimensional outlier. You may want to find out an n-dimensional outlier. What is the trick? What is the weapon to do it? The weapon to do it is through an algorithm which is called as anomaly detection algorithm. I repeat, anomaly detection algorithm. IBM SPSS and IBM SPSS as well as PASW modeler. which was formerly called as Clementine. Both of these tools have this particular algorithm, which is called as anomaly detection algorithm, which can be used to identify an n-dimensional outlier. But anomaly detection algorithm, anomaly detection algorithm is not something which is part of this particular presentation. That is a separate discussion. I'll make a separate video on that. Thank you so much for watching my video. Please do like and subscribe to my videos. I'll see you in the next video. Namaste and a very good morning to all of you. My name is Mithu, and in today's presentation, we'll be looking at two-way analysis of variance. What exactly is two-way analysis of variance? Firstly, even before I answer the question as to what is two-way analysis of variance, let's take a step back and understand as to what is one-way analysis of variance. One-way analysis of variance is an extension of independent sample t-test. One-way analysis of variance is used to compare three or more groups present in one categorical variable. I repeat, it is used to compare three or more groups present in one categorical variable. What happens if instead of one categorical variable, we have two categorical variables? When we have two categorical variables, we can't use one-way ANOVA. We move on to another form of ANOVA, which is called as two-way analysis of variance. Two-way analysis of variance is used to examine the influence of two different categorical independent variables on one scale variable. I repeat, two-way ANOVA is used to examine the influence of two different categorical independent variables on one scale variable. To see how two-way ANOVA works, let me show you how two-way ANOVA works through a practical example. I'm working on SPSS. Let me access a file which is called as grocery_1 month. To do this, I will choose the file menu, click on recently used data. Right at the top, you see grocery_1 month. As the name itself suggests, this file, grocery file, talks about customers who visit a shop to buy grocery items. You can see people's purchase pattern. The first customer, whose ID is 1, is a male customer. He purchases bi-weekly and he purchases in bulk. And the amount that he has spent is $416. Second customer again is a male, bi-weekly customer. He buys in bulk, and the amount that he has spent so far is $383.24. Third customer buys weekly similar items. The amount that he has spent is $577. So on and so forth. As you can see here, if I had only one categorical variable, I would have used one-way analysis of variance. But there are two categorical variables, namely shopping style and gender, to find out what is the impact of these two categorical independent variables on the scale variable, namely amount of money spent. We will be using the two-way ANOVA. To perform the two-way ANOVA, what we can do is go to Analyze. I will choose the sixth option from the top, which is called as General Linear Model. It offers 4 different options. I will choose the very first option called as Univariate. Once I click on the option of Univariate, a new dialog box pops up. SPSS here is asking me for the dependent variable and the fixed factor. The dependent variable will be the scale variable, namely amount of money spent. When it comes to the fixed factor, I can choose gender as well as shopping style. Now, there are a whole lot of options that are present to the right-hand side top corner. You can specify your own custom model here. I will choose the model tab to do this. Let me click on the model tab. A new dialog box pops up. Here, by default, the full factorial model is used. I will choose the second option, namely build terms. I can choose gender and request for the main effect. I also need the main effect for the variable shopping style. And finally, I need the interaction effect of gender and style. By default, the sum of squares that is used to test the hypothesis is type 3. There are other options as well for sum of squares, like type 1, type 2, type 3, and type 4. I will not disturb the default settings. I'll choose the option continue. I will ignore the option contrast.
I would like to see a visualization of what is the impact of each of these variables on the dependent variable. So let me click on the option plots. It is asking me for the horizontal axis and separate lines. Along the horizontal axis, I will choose shopping style, and I would request separate lines with respect to the variable gender. So style along horizontal axis, gender along separate lines. Now I can choose the option add. By default, SPSS produces a line chart. If we want, we can also change this to a bar chart. Let me choose the option continue here. Do I want to perform a post hoc test? Yes, I do want to check for the post hoc test. So let me click on the post hoc test. I want to check for the post hoc test for the variable shopping style. You can see here, there are different options when we assume equal variances. I will choose the option Tukey's test and then say continue. I will be ignoring the EM means method. I don't want to save any new variable. Let me click on the options. Here, I will be requesting for the descriptive statistics. If you want, you can perform the homogeneity test. I will ignore this for time being. We can also evaluate the parameter estimates. I will again ignore this, and I will just choose the descriptive statistics. I'll click on continue. So with this, we are ready to perform two-way analysis of variance. Two-way because, as you can see here, I've got two categorical variables, gender, which is broken down into two groups, namely males and females. I also have the second categorical variable, shopping style, which is broken down into three groups, bi-weekly customers, weekly customers, and people who come often. So let us check what is the impact of these two variables on the amount of money spent by the customer. Let me click on OK. SPSS gives you a lot of output here. In the output window, you see a lot of options. Let me first go to what is called as the profile plot. And as you can see here, this plot is very, very useful to understand what is going on in the data set. As you can see here, in the x-axis, we have the three types of customers. Bi-weekly customers who buy in bulk. Second, we have weekly customers who buy similar items. And thirdly, we have customers who come often and buy what's on sale. You see two different lines here. The blue line corresponds to males and the red line corresponds to the females. The y-axis here is the estimated marginal mean of the variable amount of money spent. In the y-axis, we have amount of money spent. So let us interpret this particular chart. What you see here is very, very interesting. It looks like when you compare bi-weekly customers, men spend a bigger amount as compared to women. So male customers who visit the shop bi-weekly outspend female bi-weekly customers. When you look at the weekly customers, the same trend is observed because male weekly customers outspend female weekly customers. When you look at the last category, this is very, very interesting. The two circles are very, very close to each other, which means that when it comes to the often category, males who come often and females who come often spend almost the same amount. They spend close to $400. So this is the output of the line chart, or what is called as the profile plot. Now, let me go to the descriptive statistics. The descriptive statistics, you can see a lot of numbers, but let us not be intimidated. The descriptive statistics is just a reflection of the numbers that we use to construct the profile plot that you saw here. Let's try to understand descriptive statistics. Here you have males, and then it is further broken down into females, and here we have the total. When we look at male bi-weekly customers, weekly customers, and often customers, the biggest number is 440, and that corresponds to weekly customers. So it looks like male weekly customers who buy similar items are most profitable as compared to the other customers. We also have other important information like standard deviation and the sample size here. Let's look at the female category. We have three groups here: bi-weekly customers, weekly customers, and often. The largest number that I see here is 405, which means, again, from among the different shopping style, females who visit the shop often and purchase what's on sale seem to be more profitable as compared to the other categories. We also have the description of total. Here, bi-weekly customers, weekly, and often. When we compare, the often customers, people who come often and people who purchase weekly, seem to be very, very close to each other because they spend $404 and $406. If you scroll down, the descriptive statistics and the profiles plot are very, very useful. But if you want to look at statistical evidence, this particular table, that is the test of between subjects effect, becomes very, very useful. As you can see here, we have the corrected model, then we have the intercept, we have the first categorical variable, namely gender, the second categorical variable, shopping style, the third variable, namely the interaction effect between gender and style, is also reported. I have error, total, and the corrected total. I have the type 3 sum of squares being used here. It also gives you the degrees of freedom and the mean square. We also can see the F statistic that is being reported here. The last column is very, very important because this column is the significance level. What we do with the significance level is we take this number and compare it with 0.05. If the significance level is less than 0.05, we can conclude that that particular categorical variable is having an impact on amount of money spent. On the other hand, if the significance level is bigger than 0.05, we can conclude that there is no evidence to suggest that this particular categorical variable is having any effect. Let's inspect this one by one. Let's look at the first categorical variable, gender. And as you scroll to the right side, you can see the significance level corresponding to gender as 0.000. 0.000 is less than 0.05, indicating that we have to reject our null hypothesis and conclude that there is a significant difference in the amount of money spent between the males and the females. So gender is having a very profound impact on the amount of money spent. Let's now look at the second categorical variable, that is shopping style. We can see the significance level being reported here. It is 0.140, which is greater than 0.05. 0.140 is bigger than 0.05, and therefore we fail to reject our null hypothesis and conclude that shopping style is insignificant. The third variable is very, very interesting because here we are looking at the interaction effect between the two variables, namely gender and style. And when you look at the interaction effect and the significance level corresponding to the interaction effect, the value is 0.017, which is again less than 0.05. 0.01 is less than 0.05. Since significance level is less than 0.05, we reject our null hypothesis and conclude that there is a strong interaction effect. So these are some of the important insights that we can pick up from the test of between subject effects. That is, shopping style is insignificant, whereas gender and the interaction of gender with style is very, very important. Let's now scroll down and look at the results of post hoc tests. Here, we are doing a pairwise comparison among the three groups. When we first look at bi-weekly customers, we are comparing it with weekly customers. We are taking a simple mean difference between the amount of money spent between the bi-weekly customers and the weekly customers. And when we take the mean difference, that is negative 26.03, is that significant? When you look at the significance level, it is 0.09, which is greater than 0.05. And since it is greater than 0.05, we fail to reject our null hypothesis, and hence we conclude that there isn't a significant difference between bi-weekly customers and weekly customers. What about bi-weekly and often customers? When we compare these two groups of customers, that is people who visit the shop twice a week and people who come often, there is a difference of $28.24. We have the standard error and the significance level. The significance level is 0.193, which is bigger than 0.05. And since this number is greater than 0.05, we fail to reject our null hypothesis and conclude that there is no significant difference between the bi-weekly customers and customers who come often to the shop. We also see the 95% confidence interval being reported. That is, the lower bound as well as the upper bound for the mean difference is reported here. We can see further subsets being provided. This is the output of Tukey's HSD. We can see there are three groups, the sample size and what is the average spend is being reported. Now this I am going to ignore, and we have already seen the profiles plot, which means that a couple of important insights that I can draw. One is that shopping style is not having an impact. Gender is having an impact. The interaction between gender and shopping style is also very, very important. What we can do now is we can go back to the dialog recall. And as you can see here, the last performed action is univariate. The moment I click on the univariate option, the general linear model univariate option pops up. I can go to the plots, and instead of the line chart, if you want the bar chart, that again can be requested. So let me choose the option bar chart, click on continue, and then say OK. These numbers and descriptive statistics we have already seen, but this is something which is new. Either we can report the descriptive statistics in the form of a line chart or in the form of a bar chart. Very, very interesting. You see the three types of shopping style: bi-weekly, weekly, and often. The blue bar corresponds to males and the red bar corresponds to females. For the first two groups, namely bi-weekly and weekly, the blue bar is longer as compared to the red bar, indicating that the male bi-weekly customers outspend the female bi-weekly customers. I can make the same conclusion about the weekly customers because the male weekly customers outspend the female weekly customers. But when it comes to often customers, whether you're male or a female, by and large, the amount spent is very, very close to each other. So this is how we can perform the two-way ANOVA. When we have two categorical variables, we can compare between the groups. We have looked at post-hoc tests. We have looked at the profile plots. We looked at both the line chart as well as the bar chart. Depends upon which chart do you want to show. And we also looked at other important information as far as two-way ANOVA is concerned. With this, I have come to the end of today's presentation. I thank you very much for watching today's presentation. If this video has benefited you, I request you to hit the like button and subscribe to my channel. Thank you very much. Have a great day.